Okay, good day, everyone. Thank you for joining us for this webinar presentation. My name is John Clements, and I'm the technical lead for the Homeland Defense and Security Information Analysis Center, or HDIAC, one of three IAC domains in the DoD Information Analysis Centers, operating under the Defense Technical Information Center, or DTIC, within the Office of the Undersecretary of Defense for Research and Engineering. Our informative webinar series highlights current and emerging research and technology developments. It presents an opportunity for accelerating the DoD's leverage of these advancements by increasing awareness and fostering technical collaboration. So HDIAC serves as one of the premier information research partners and curators of technology advancements and trends for the Homeland Defense and Homeland Security communities. As such, our organization supports those working in Homeland Defense and Security domain of DoD research and engineering. We do this by helping navigate the vast landscape of scientific and technical information, allowing our customers to get a head start on their technical projects. We provide research and analysis services to help unlock access to information, knowledge, and best practices from government, industry, and academia to stimulate innovation, foster collaboration, and eliminate redundancy. We hope you enjoy this webinar and that it serves as a catalyst for community collaboration and improved DoD Homeland Defense and Security research. So before we begin, I will note a couple of administrative items. First, if you are dialed in by phone and would like a copy of the slides, they were posted to the HDIAC webinar announcement. You can go to hdIAC.org/webinars and find today's webinar. When you click on it, at the bottom of the announcement, it'll say to view the webinar PDF, click here, and you can download the presentation from there. Second, all participants are muted, but you can chat with the presenters and moderators using the chat box to the left. However, if you would like to pose a question for the Q&A session at the end, please use the audience questions tool at the top center of your screen. It is the icon that looks like a chat bubble with a question mark next to the little emoji. At the end of the presentation, I'll go over the Q&A, and for the benefit of those on the phone, I'll make sure I read the question out loud to the presenter so that you can hear the question and his answer. And if you have a technical issue during the presentation, have no fear. The full presentation will be available online. Check back on the HDIAC website, and you'll get an email notification that the webinar has been posted. And when you go to the website, if you click the Go to Webinar button, it'll take you to the YouTube link at that time. So with that, I'm going to introduce today's presenter, and that is Dr. Robert P. Garner. Dr. Garner was born and raised in the foothills of the Great Smoky Mountains of eastern Tennessee. His graduate education culminated in a doctorate from the University of South Carolina School of Medicine in the Department of Physiology. Postdoctoral training included research at the University of Alabama at Birmingham Medical School and at the University of Oklahoma Health Science Center in Oklahoma City. It was from this position that his career in aviation started. Dr. Garner joined the FAA in 1992 from his postdoctoral position at the Health Sciences Center. For 12 years, he served as the leader of environmental physiology research program at the FAA Civil Aerospace Medical Institute in Oklahoma City. Collaborations included projects with industrial leaders in both the United States and Europe, the U.S. military, and academic institutions. In the fall of 2004, Dr. Garner left the AA to start Odyssey 2 Solutions, OIIS. The initial concept underlying OIIS was to provide airframe and aviation equipment manufacturers additional product research and development and certification options for human protective systems aboard aircraft. This was primarily driven by Boeing's interest in developing new technology for 787 transport aircraft. In their interim since its founding, OIIS has acted as a consulting and research organization for developing solutions to challenging issues in various venues. Professionally, Dr. Garner has been a member of the Aerospace Medical Association, the SAFE Association, American College of Sports Medicine, and the Society of Automotive Engineers, and has regularly participated in the military's Oxygen Standardization and Coordination Group. He is past chair of the SAE Aerospace Oxygen Equipment Committee and currently serves as the chair for the SAE Systems Group of Technical Committees. And with that long introduction, Dr. Garner, I will turn it over to you.
All right, thank you. Good afternoon, I guess, to everyone. you probably now know much more about me than you ever would have cared to or need to, but that's all right. It has maybe it will help understand some of where this presentation is coming from. Now, in terms of that, you might ask, based on that introduction, what has any of that got to do with exercise? Basically, my background, I actually started with an interest in exercise many, many years ago, as you will see from, or may have already seen in some of the slides. And it has been tightly integrated with my work in aviation through the years. Basically, what this particular presentation is very tightly linked to is the use of exercise, use of hypoxia to facilitate the conditioning past the conventional boundaries. Now, just a general overview. The focus herein might be considered analogous to a case study on performance. The mechanisms that I don't know how, again, not being familiar with any of you, but the mechanisms of adaptation deserve presentations, a book, years of study. Today, when we think of hypoxia, which will be sort of a cornerstone of what we're going to be discussing today, you actually have to look at subsets of extensive academic endeavor, both in terms of exercise, altitude, environmental adaptation, or athletics. Another thing, I think I just received a note. Please do submit questions that we can discuss at the end. And I'll try my best. There's going to be a lot of areas open here, as you might imagine, that we can address them accordingly once the presentation's over with. Thanks for doing that. And again, what we're going to talk about, or what the specific approach here, and is what I'm referencing, is altitude hypoxia training. Now, this particular subject, for all of you that are familiar with exercise and maybe training at altitude or altitude acclimatization, this particular subject of training at altitude or using altitude to facilitate adaptation has been around for many, many years. And herein, I'm distinguishing it from the intermittent hypoxia training that you see in much of the literature. Has been used more often and is more generic in relationship to what the approaches have been. And there have been many different approaches, which I'm not going to even attempt to start going into in context of this presentation. Okay, now just a brief background of information about where this came from and how it relates to altitude. In these just sort of sample papers of work that I've done through the years, hypoxia has been part of my research. Very early on, I was looking at some ventilatory kinetics, and subsequently, as part of what we did at the FAA, we looked at both cognitive and physical performance characteristics at low altitude hypoxia, and then more recently, both originally with the 787 program, and more recently, in the last couple years, I modified a alternative gas delivery technology to actually develop a certification basis for portable oxygen systems. Now, one of the reasons I mention this is not so much that the papers are cutting edge, or the work's cutting edge, and so to speak, but to basically emphasize that through all these years and working with this at different levels, I was developing insights and putting together thoughts about how to actually exercise might be used, since it had been an interest from early on in training and application to various endeavors. That being the case, I guess what I'm trying to convey here is that I just didn't necessarily make this up out of thin air. It's actually built on quite an extensive amount of effort and research through the years. And although a lot of the parameters need to be strengthened, more investigation needs to be done, even in this limited application, that it is based on real data that has been collected and published throughout the years. Okay, again, I'm not certain how many people are that familiar with exercise, but just some very, very basic training routines overview, general characterization of workouts or training. What we're trying to elicit in one way or another is physiological adaptation. I guess if you applied a broad enough spectrum in certain skill sets, you could include neurological adaptation along with that. As one sort of the basic construct of training of any type is that it's specific. Marathoners trained to run marathon. Powerlifters trained to do power type endeavor, or power athletes trained, to develop power specific to their endeavors. And as a broad generalization, we generally end up training for endurance or training for strength. Again, I know that's a pretty simple characterization, but the reality is the body, the molecular mechanisms underlying all this stuff, not everything, you can't actually optimize every aspect in the performance characteristics of a sport or any endeavor, really. But, however, out of all of this, there is a concept, and that concept seems to be maintained through the years, that altitude, that is hypoxia, exposures can facilitate adaptations, particularly in terms of the underlying cellular machinery that optimizes the use of oxygen to produce energy. All right, now, to take this to sort of the applications in the real world, I want to briefly just mention the exercise and oxygen industries. There's a product that has been marketed for many years. It's called CVAC. It stands for Cyclic Variations in Adaptive Conditioning. I don't know, again, how many people are familiar with that particular methodology. They make a lot of claims in terms of how it facilitates performance and many other aspects of existence. But basically what a CVAC system is a small pod that they basically take to altitude and they change the altitude, change the pressure in the pod very quickly back and forth. And they've got different routines that they claim do different things. It is not difficult to find information about this approach and how different people implement it. If you're interested, I'd certainly suggest that you take a look at it. It is somewhat interesting because they have been a fairly commercially viable entity in their approach. There is what's called exercise and oxygen therapy, very similar to CVAC. This approach is commercially promoted by many different people, as are other names that offer very similar approaches with mixed gases, called Live O2 and Max O2, and I'm sure there's many others out there. It's not necessarily trying to recommend or promote or detract from any of these approaches. What I'm actually trying to get at is that there's this concept of using hypoxia or hyperoxia to produce positive results in life or in athletic activities is pretty pervasive throughout the world. Again, there's this oxygen, I forgot to mention it, there's this oxygen multi-step therapy. There's this Dr. Von Arn, there's literally a book out, and he has clinics all throughout the world through the various administration of different gas mixtures, supposedly does all, supports all types of clinical capabilities, not only to health, but various disease states. And if you do a search on any of these things and look on the internet, you'll see that there are various physicians and health and exercise professionals that in one way or another are claiming that they do these things to help folks. Now, again, I don't want to promote or detract from any of this, but one common characteristic that I have noticed in trying to research and look at the details of it, that most of it seems to be really long on theory and correlational data, but short on truly quantitative results. Now, this is what is in the evidence and how I actually came to start what this might be, even like I said before, might even be considered just a case study, is that hypoxia training has become very popular in the athletic community. Now, in part of the work that I was doing directly related to aviation safety equipment in Arizona, one of the individuals that had been participating in that testing protocol was actually a very accomplished coach for professional athletes. Now he did, other people were done as well, but he was in a training facility in Arizona in the Phoenix area, actually Scottsdale, that actually supported many professional athletes in the combat sports arena. Now, there is obviously a belief among these athletes that hypoxia training potentiates performance improvements beyond sea-level equivalent training. Now, there's some contradictory evidence, and this is really about the only paper that I'm going to mention in going through all of this. Is that the quote that I presented here is functional translation in terms of whole body performance enhancement is minimal. Now, as I mentioned before, there's an extensive body of research and associated publications related to exercise training. And depending upon what your personal belief might be, you can pretty much find evidence to support any view you might have. Some people have found in the protocols that they use, there's not a whole lot of difference. That if you control for everything, it really just comes down to how you're challenging the body. And if you do the identical challenge at ground level, performance at altitude is equivalent. Others basically believe and feel they've demonstrated with their protocols and arrangements just the opposite. So I would suggest that if you really have an interest in this area after the seminar, you can look for some of this research. Contact me. I can share if you have, again, in today's world, you need a very specific interest because hypoxia has become is that important to human endeavor in general, as we now know from clinical applications. And again, I have a ton of research and background information that I would certainly be willing to provide or discuss with folks as to what literature might be most pertinent to their interest. Now, okay, development. The slide, I guess, slide's a little off here. I apologize for that. I don't know in transition to what's going on, how that happened. But anyway, most believe that definitively the characteristics of the training stimulus are unclear. The modality is obviously important. As I mentioned on the last slide, there's a lot of people who have produced evidence where it looks unlikely. There's other people who have produced evidence where it would seem to be very likely. But nobody really breaks it down and does exactly the same thing. They all do sort of pretty much, most people have done taken fairly different approaches in how they've set up their experiments and ran them. The one thing we can say with a fair amount of certainty is the modality of exercise is very important. Now, as I mentioned earlier, the AHT, what I'm calling the AHT approach, is built on experience in exercise science and human exposure over a range of altitudes. I mean, over the course of my career, I've had these exposures ranging from 5,000 to 45,000 feet. And all of that collectively is sort of played into what I have developed here, just from both the data and sort of witnessing the qualitative experiences and talking with participants throughout the years. What I've done herein is basically leverage variations in workload at altitude as a function of aerobic capacity, specifically the VO2 max, and the anaerobic threshold. I sort of had an idea, and as we'll see in subsequent slides, it had to be adjusted a little bit. Okay, now, in developing this, and again, it was done really in the context of working with the folks at the training facility. The thing that I had to raise awareness about is that there are some inherent risk related to altitude exposure. The idea, if you're going to be training people, and if you're subsequently going to train a population beyond maybe the professional athlete, professional athletes, which actually ended up using a professional athlete in this study, to other populations, you've got to minimize across all of them the known risk factors. And at altitude, there's an issue of bear trauma. At these altitudes, it'd be highly unlikely, but in terms of time exposures and some of the altitude profiles that are used, and such as the CVAC, decompression sickness is not beyond the realm of possibility, and then there's other pressure issues as well. Now, you want, in terms of the training challenge, you actually need something that is inherently challenging. I mean, you actually have to stress the system that you're trying to bring about improvements in. Now, conversely, if you're considering altitude, you've got to come up with something that ultimately is not incapacitating, because exercise at altitude due to the decreased oxygen pressure is more difficult than at ground level. And we know there are fairly specific relationships explaining that, which went into what we have done here. Now, my idea was that you have a variation in the exercise and altitude challenge, or the altitude exercise that presents a complex challenge, which would in turn elicit stronger adaptive responses in the individual over the course of training. Now, you've obviously got to do this in a time frame consistent with allowing feedback and associated responses of the individual over time. Well, and actually this applies to both individual sessions as well as over time of the training program itself. Now, what I ended up with in terms of the altitude exposure, as you can see here, and it was actually ended up at 12,500 feet, was you initially start at about 12,500, you drop to 7,000, go back up and over. Now, the initial part of it, I was up through, I guess, about minute 720 here, I was pretty consistent with. What you're seeing here is on the next slide, there's some different individuals, and we reviewed their data, had them do, again, slight modifications related to what their VO2 max and anaerobic threshold was, and then there was consideration of how long do we actually leave these people at altitude in terms of the training regime. Now, what this slide is showing is 3 different individuals, and as usually is the case, this has been discussed with people on more than one occasion. And if you're looking at these slides in the future, if you've looked at them before, notice this. These 3 different lines, which represent 3 different individuals, this should actually be work rate, not altitude. So I apologize. I don't know how many times I've looked at this set of slides and that slipped through. So just be aware of that. We weren't changing altitude this fast or in this short of a time frame. But what we did here were people that were in a little bit different, for lack of a better term, fitness levels. We varied the time frames and the work rates that they went to across the altitudes that were shown before. And we did stumble across a couple times that are circled in red down here, where in pushing to the work rates we had originally anticipated, they basically couldn't complete the work. In the work going to zero, we had to essentially stop and let them rest for a few minutes and recover. And somewhat interesting is one individual that occurred fairly early on, or not early on, but sort of in the middle of the program. Another one, it was a little bit later, which basically was then used to go back and adjust the work rates, the percentage of VO2 max and anaerobic threshold that was actually being applied to establish a work rate that we thought would, you could basically put in an individual's numbers, and then it would use an algorithm to basically predict, okay, what work rate do they need to be doing at the various altitudes. All right, now, this is on this slide. It is heart rate and work rate over on the left-hand axis. Altitude is displayed on the right-hand axis. And as you can see, this is sort of a slide of how these things actually interact for one of the individuals that we had doing the exposures early on as sort of a test case before we actually tried to start to implement a series in an individual for actual a training protocol. And as you can see here, they're going along a certain heart rate at altitude. As they start exercise, it goes up, and heart rate's maintained throughout the program, even though altitude and exercise varies. And this is sort of what we were looking towards, that you're always getting a challenge and recovering from it and then getting a new challenge. And the complexity of those interactions produces a little bit more adaptation than what you would do by just simply running or riding a bike at altitude or ground level or some combination thereof. Now, the question came along in our mind, how can we best demonstrate effectiveness? And there's a lot of considerations here, obviously more than I'm actually going to address, but I also want to use this moment to identify that this presentation, what we've done, I think is suggestive. It's certainly not definitive. So just want everybody to know that I recognize the limitations of what has been done, but I do think it suggests an interesting adaptation because of the individual we used to a very specific training. But you want to look at a number of people. Obviously, you have to define some type of control group, which is somewhat difficult to do at altitude because there's hard to be an internal control. Anything you do is similar, and there's always the aspect that if someone does something in altitude, if they do the same thing at ground level, it's not exactly the same stimulus. If you bump it up to the same stimulus, are there mechanical issues and neurological issues that might also play into the adaptation? Those are the types of things that people that work in this area, particularly on the exercise side of the ledger, are concerned with. Another aspect is fitness levels. I mean, if you look at a sedentary individual, is that pretty much anything's going to elicit improvement. The other, if you use an active population, you have to worry about an interaction of activities And then as well, there's potential synergistic effects from the activities that they are doing versus the activities where things have been done at altitude. Now, in the highly trained or the conditioned individuals, it's much harder to elicit changes. So again, all of these things have to be considered, and that's probably why there's a lot of debate and discussion within the studies in this area, because they're actually looking at very different questions through the experimental protocols that are employed. All right, now I'm going to zip through this, hopefully a little bit quicker, but how we ended up using a professional athlete that was interested in altitude training, as he was actually training in Scottsdale uh, with this group, and again with this individual that was a coach over there. He was a competitive heavyweight fighter. He basically fights as a function of Bellator. He was 8-1 at the time. Pretty good ability as an athlete. Had played uh, college ball at a major university. Had always been in athletics. He was 29, 6'2", 265 pounds. His VO2 max was 43.2 mLs per kg, and his anaerobic threshold came in at about 27.2 mLs per kg. The work rate that we ended up using was based on the preliminary evaluations as expressed through the algorithm that we had finally settled upon. Now, here's sort of a key component of what we've done here, or not done here, I guess, as you might view it, is that the AHT was done in addition to his normal training. I mean, his regular training in terms of his running, cardiovascular, weights, everything like that, the AHT was done in addition to that, not instead of it. Originally, we had hoped that the comparison was going to be in the magnitude of changes in the VO2 and anaerobic threshold before and after the training that induced AHT. Unfortunately, due to the management of the pandemic by the various organizations involved and these professional promotions, the schedule changed so much, we didn't have an opportunity to really get the post data. But one thing that did happen that really is why I find this somewhat interesting is that, again, due to some scheduling issues, there was a break in the AHT training after it had been ongoing for about 4 weeks, 4.5 weeks. Now, before the break, this is his response. Again, heart rate and work rate are on the left-hand axis. Altitude is on the right-hand axis. This is his variations in work rate. We see his heart rate response. Again, here I'm pointing. I might have been a little misguided here. This is John. Can you guys see my pointer?
No, unfortunately, we cannot, and I don't think on our platform there's a way to show
Okay.
it.
Because I've been pointing at things, and I just realized that they may not be able to see what I'm pointing to. So again, probably a little late, but I did want to check. Anyway, towards the end of the altitude exposure, you can see at 12,000 feet, he's working at 240 watts on a cycle ergometer. That's a pretty fair amount of work. And again, it bounces around and up and down and elicits the heart rate response demonstrated. Now, in the next slide, what we did, and we're calling this after the break, he had about a 2-week break from the AHT. And what we are showing, or what I'm showing as comparison here, is the pre and post heart rate and the pre and post work rates. And to make a relatively long story short, and this is over towards the second altitude exposure, and then the second high altitude exposure, and then in the final altitude exposure, he could not maintain the work rate that he had been able to perform as the AHT progressed in his initial training. Now, what I think is very interesting about this particular point is that his training did not stop over the time course, about 2 weeks, 2.5 weeks, over the time course that he wasn't doing the AHT. He was still doing his normal training that was involved with him being a professional athlete. So that struck me. I mean, because I'd actually originally anticipated him coming back in and taking up where we had left off in terms of his training challenge. Now, as I mentioned before, he was unable to maintain that work, while training under the AHT protocol. Again, the normal training routine associated with professional athletic endeavor continued in the interim. It's not as if this actually represented some break in which he laid off and basically underlying metabolic mechanisms could basically deteriorate a little bit. And again, the heart rate response was elevated at identical workloads and altitudes. Now, this suggests that AHT was facilitating performance capabilities beyond what normal training methodologies were eliciting. Again, I can't, I certainly want to acknowledge that I can't unequivocally say that would hold up across a population of people, but I do find it interesting that this individual who's very dedicated, could mentally push himself very hard and consistently did in all of his training, could not carry on, could not replicate even after a couple of weeks off what he'd originally was able to do. Okay, now the next steps. Obviously, you need additional people. Thoughts to be considered was, do you want to use highly trained? Originally, I had targeted both some of these professional and highly competitive amateur athletes to be involved in the program due to, again, the management of the pandemic and other issues that developed. We did not get to pursue that as we would have liked. Obviously, responses to various fitness levels and legitimate controls would want to be considered. In terms of specific training regime, I would anticipate, based on what I saw, you would have, as with many, I think is the minimum for most physical activities that people become involved in, you would want to train at least a couple times a week, with maybe a minimum of 2 days between sessions. There's some debate here on what the approach might be, but again, it would have to be integrated with the general protocol of what markers you were using to evaluate adaptation. There would have to be decisions made about the integration or comparison with ongoing training routines, and certainly the more precisely we can characterize performance parameters, the more insight we might actually be able to gain in terms of how things are working. Okay, just some sort of executional issues related to doing this type of training. Chamber time and support obviously is critical because in one of the huge benefits that CVAC claims that you just have to sit there and the fluctuation in altitude is what actually elicits the benefit. Obviously here you have to have a chamber large enough to have the person exercise. Exercise modality might also come into play. But the way I set this up by design was to get the person in and out in an hour from the entry to the exit. So the training actually takes, I think it was about 26 or 27 minutes. But in this case, you come in and there wasn't a lot of instrumentation in this case, but you basically instrumented the subject, had them finish, give them time to cool off, and then leave. Of course, there's monitoring. You've got to have some supplies to support it. And, in some people, you are probably going to have to make some adjustments over time. It would be nice if you had. I had a commercially available VO2 max system. It was a little bit older, but I think it was accurate. But the better resources you have for evaluation in terms of VO2 max, ceramic anaerobic threshold, and I think it'd also be important to uh, have pulmonary function data on these individuals. I think that would both provide not only more information, but with as newer technology come out, higher resolution information, which for the most part is always beneficial. Some other things that I would like to monitor during training is direct measurements of respiration, maybe do lactate, maybe sporadic and lactates, maybe gas exchange. Uh, in some cases, with the amount of work that has to be done, gas exchange and some of these other things could be a little bit of a challenge in terms of doing it every exposure. But let's say if you had a 12-week training program, maybe doing an exposure, standard exposure every 3 or 4 weeks uh, would be really valuable. Now, in terms of monitoring across training exposures, some basic blood markers would certainly be of interest. The group I was working with at the time related to more of the fundamental physiological aspects. We were wanting to look at erythropoietin, potentially the hypoxia-inducible factor that there's been a lot of work done in, but then you also realize in looking at some of these things is that they have become scientific. I mean, the different aspects of the HIF pathway has become scientific endeavors within themselves. So in doing all of that, you certainly would want to develop and target uh, what the primary interests were and what would be the best way to go about it in terms of your study protocol. Okay. That's really, I think, we're certain might be a little bit under what the allotted time was, but I think uh, that would be good. That primarily covers what I have to say at this point. Certainly would be happy to address any questions someone might have.
Yes, I have. I do see one question that came in on the chat. Just give me 1 second. I'm going to post it up in the Q&A here, and then I'll read it off to everyone. It should be shown on the screen, but this comes from Arnold Packman, and he says the variation in altitude, work rate, and heart rate is reminiscent of interval training for runners. What is the relation?
I think that's a very good question. There's two aspects of training for runners, and well, particularly for runners, but also for cyclists in this area. And again, it's endeavor unto itself. The idea is the same. The concept that, and again, I don't know this. The concept you may be thinking of is to live high and train low, and the interval training that addresses pressing the system very hard and then cutting back and then again pushing it to its limits. And I think those the approaches are very similar. In fact, what I've done sort of build upon some of the high, I think, not just for runners, but the concept of high intensity training that has been recently popular. Another aspect that might be related to this is there's some of the commercial fitness equipment where they look at these interval bursts or switching to high intensity segments of training and then backing off. And there is data that suggests that this high intensity training will elicit more quickly and just as a well, actually by being more quickly, is more efficiently elicit some of the adaptations, the cardiovascular metabolic adaptations that historically people had thought that you had to uh, spend much more time, let's say, running 3 to 5 miles a day. And again, that's just as an example, sort of pulled out of the hat. But I think they are related. I think the same principles are applying. Uh, idea here is how do you optimize it? And again, not only, and I think the thing that we're doing by what I call optimization, or the other aspect that I think altitude exposure does, is because of the oxygen pressure and a general impact of pressure decrease on the body as a whole, it allows people to push beyond what could be achieved by just the interval training at ground level. Does that answer the? I mean, does that address his question? Or
I I do think it does. Mr. Packman, if you do want to post anything else in the yes, he replied yes, thank you. So I don't see any other questions. Oh, with that, I think that will bring the webinar to a conclusion. Dr. Garner, I'd really like to thank you. I do appreciate your time and all the back and forth in getting this prepared, and it was very informative. Um, I actually serve in the reserves myself, so I may have to implement some of this, especially as I'm getting a little older here. Uh, so appreciate your time and appreciate everyone who dialed in and spent what probably is their lunch hour with us. Thank you very much.
oh well, thank you. I enjoyed doing it. It was again through most of my career, these have been things I've added on. So again, it's nice to have an opportunity to discuss it with folks.
All right. Thank you. Have a
All
great
right, talk
one.
to you later. Bye bye.
All right. Bye.